Welcome back to another Common Core Algebra 2 lesson. Tonight we're going to focus again on polynomial long division, but specifically, what if there is a remainder? So the past couple nights we've been dividing and everything has worked out beautifully in the end. We haven't had any remainders. So let's just slow down and review what a remainder is. Let's say they asked me to divide 13 by 4, without a calculator of course. So I would say 4 is my divisor, my dividend is 13. 4 goes into 1, doesn't happen, so then I expand it and say 4 goes into 13 how many times? Well, I would say 3, because 4 times 3 is 12, and then I'm going to wrap that up and subtract. 13 minus 12 gives me 1. So we like to say we have a remainder of 1. Now how do you actually write that answer down? Well, 4 divided by 13, and here's the key, is how you're going to write it, is equivalent to 3, and 1 is left over out of the 4 you divided by. So I would say that is rewritten as 3 and 1/4. Okay? So my quotient that I got was 3, but I have this remainder of 1. I was dividing by 4, so I'm going to rewrite it as 3 and 1/4. So in this case, it wasn't, as beautiful as they've been the past few days. We had this extra remainder that we have to take care of. I would say as of today, there are 3 ways that we know how to find a quotient. And we'll talk about all 3 of them, and we'll use the same polynomials to divide. So number 1 is simply just factor. Now this one's nice because I can factor the numerator, so let's go ahead and do so. Remember, I am adding, multiplying. So I'm going to say that's x times x, and I'm going to go to my multiplying next and say, okay, I can use a 2 and a 1. And my signs, I need a positive 2, so that tells me the signs are the same, and I want to add to a 3, so plus 2 and plus 1. All over x plus 2. Now remember, anybody that you divide on the top and bottom are the same, they cancel to a 1. So basically I have 1 times x plus 1, which is really just x plus 1. So I would say the 2 factors of this polynomial are x plus 2 and x plus 1. The second method is to use long division. So let's solve the exact same problem using long division. So remember, my divisor goes here, x plus 2, and then they have to go from largest degree to smallest degree, so x squared plus 3x plus 2. And all we're doing is comparing the leading coefficients. So x times what would give me x squared? Hopefully you said x. And then we take this x, we multiply it through, so x squared plus 2x. Wrap that puppy up, put a minus sign in front. I'm going to change that minus to addition and change my signs. And the whole point is those should cancel, so I have 3x minus 2x, which is 1x. Bring down my second term, which is a plus 2. And I'm going to say x times what is 1x? Well, x times a positive 1 is 1x. So I get x plus 2. Wrap that puppy up, put a minus sign in front, change my signs, and I get those cancel, I get 0 as my remainder. The third method that we talked about was the tabular method. So again, let's solve the exact same problem with the tabular method. So I have x plus 2 as my divisor, so those go on the right side, and I just have to figure out how many columns I want. So I just say x times what is x squared? X times x, so I need an x and I need a constant spot, so I just need 2. And then this block is my x squared. These two come together to get 3x, and this last guy makes the plus 2. And the tabular method says, okay, if this is your only box here for x squared, then that has to start there in the upper left. And I'm going to say x times what is x squared? Well, that's x times x, and now I can fill in this box down here. 2 times x gets me 2x. And then I circle these and say, okay, I need a total of 3x. I currently have 2x. That would make this one a 1x. And now x times what gets me 1x? Well, that's x times 1. And then I'll say 1 times 2 is 2, which is beautiful because those match, and I know I'm correct. That was a positive 1. So again, my factor is x plus 1 times x plus 2. So that was just a quick overview of what we've done for the past couple days. Now let's take a look at this example. Find the quotient. X squared plus 3x plus 5 divided by x plus 2. What method do you use? Well, if you can factor, I would always do that. But if you notice, the only factors of 5 are 1 and 5, and those will never make a 3. So method 1 of factoring is out. Method 2 or 3, I can use long division or I can use the tabular method. So we might as well just try both and show you what happens when we have a remainder. So let's start with long division. My divisor is the x plus 2, and then again in order from largest to smallest degree, x squared plus 3x plus 5. Comparing those leading coefficients, I would have to multiply by x to get x squared. So if I multiply by x, I get x squared plus 2x. Wrap that up, put my minus sign in front. I'm going to switch that minus to a positive and switch these terms inside the parentheses. So then those cancel, and 3x minus 2x gets me 1x. Bring down the positive 5. And again, compare the leading coefficients. X times what is 1x? Well, I would say x times a positive 1. So now I get x plus 2. Wrap that up, put my minus sign out front, change my signs, put that a plus, make that a minus, and that a minus. Those will cancel, so I know I did it right, but this time you'll see I have a remainder of 3. So just like we divided in that first example, remember we had 3 and 1/4? Maybe look back to your notes. What we're going to say is our quotient is x plus 1, that's what we got up here, plus a remainder of 3 over the divisor x plus 2. So I want you to box this in. This is the entire final answer. This is what I got when I divided the x plus 1, and then my remainder over this quantity. Okay, so now let's try the exact same example, the x squared plus 3x plus 5 divided by x plus 2, but this time we'll use the tabular method. So I'm going to go ahead and set up my table. I'm dividing by the x and a positive 2. Okay, so that side's always simple. Now, to figure out how many columns we need, we said look at the leading coefficients. X times what is x squared? Well, I would just need 1x and then a constant. So I only need 2 columns this way. All right, I'm going to put my answers in. I know this is going to make x squared. These two will make a positive 3x, and this last term, I need to make a 5. So hopefully you remember, we just put our answer in the first box, okay, and then we'll say what times x is x squared, and that's just x. Then I can fill in the rest of this column, so that would make this one 2x. Then say, okay, I need this diagonal to make a total of 3x. If this is 2x, then this will have to be a 1x. So x times what is 1x? Well, that would be a plus 1. And then if I find this one, I get an answer of 2. Now you'll notice we'll have a little bit of a hiccup here because I'm supposed to get an answer of 5. So that's not telling me I did it wrong, it's just telling me there is a remainder. So I'm just going to say I have 5. If I take out the 2 that's left, the difference is 3. So again, I should be getting the same thing. I'm left with x plus 1 plus my remainder over my divisor. So whatever method you prefer, whether it was long division or tabular, you should get the same thing. So let's try another one. We'll do it both ways again. We'll first start with long division. So I'm going to say that's x minus 2 divided by x squared plus 2x plus 4. So maybe I'll hold up and wait a minute. And could I factor? Let's go back to that example. I mean, because factoring is always easy. So let me quickly check. I have to multiply to 4, but add to 2. So my only options are 4 and 1 or 2 and 2. And none of those can add to 2. So I know factoring's out. So I'm going to set up this long division problem. All right, compare the leading coefficients. Let's see, I have to multiply by an x. So that gets me x squared minus 2x. Wrap her in parentheses, put my minus sign, change my signs. Those cancel, so now I get a 4x plus 4. Compare those leading coefficients. Looks like I have to multiply by a positive 4. So that gets me 4x minus 8. Wrap it up, put my minus sign in. Switch the signs. Those cancel like they're supposed to, so now I have, let's see, a remainder of, oops, where'd my pen go? A remainder of 12. So I would say that this answer is, what was my quotient? X plus 4 plus my remainder over what I divided by, so the x minus 2. Okay, so now we'll do long division and see if we get the exact same answer. So I have x squared plus 2x plus 4 divided by x minus 2. Okay, so when I set up that tabular again, I've got my x and my minus 2. Compare those leading coefficients, an x squared to an x. I would have to multiply by just an x, and it needs a constant. So I know I have two terms going this way. And then I'll put my solutions in. So this box has to total x squared. These total 2x, and this is supposed to total 4. And right away we can stick in that first term, the x squared. So what times x is x squared? That would be x. Multiply down, and I get a negative 2x. Okay, so now I work this diagonal and say, okay, this diagonal has to total 2x. I currently have a negative 2x. I'll need a positive 4x. And then x times what is 4x? Well, that's just a positive 4, which will give me down here a negative 8. Okay, so now I have to get that remainder. I'm just going to say it's what I want minus what I got there, a negative 8, so I get a remainder of 12. So for my final answer again, I would say that's x plus 4 plus 12 over the divisor x minus 2. So you can say with either method, you get the same answer. It's pretty much just, a choice of what you feel more comfortable with. Do you like the long division or the tabular? All right, find the quotient using both long division and the tabular method. Now, this one's a little uglier. Can you see why? It starts with x to the 4th, but it doesn't have all the terms. We're definitely missing the x cubed and the x term, so we'll have to be real careful when we set this up. So my divisor is x plus 2, and I'm carefully going to divide by x to the 4th. We need them in order. I have 0x cubes minus 8x squared plus 0x's plus 12. So remember how important it is to make sure you put those 0 placeholders in. All right, so we'll compare those leading coefficients. So it looks like I'm going to need an x cubed. So when I multiply, I get x to the 4th plus 2x cubed. Wrap it up, put the minus sign in front. Now we'll go and change the signs, plus, minus, minus. Those cancel. So I get a negative 2x cubed. And I'm going to bring down the minus 8x squared. Okay, we'll compare leading coefficients, x to negative 2x cubed. So I'm going to need a negative 2 and an x squared. So that's going to get me negative 2x cubed minus 4x squared. Wrap it up, minus sign, change the signs. Those cancel, and this gets me a negative 4x squared. Okay, I'm going to bring down my 0x's. And I'm going to say, compare those leading coefficients. X times what is negative 4x squared? I'm going to go with the minus 4x. Multiply that through. So it's going to get me negative 4x squared minus 8x. Wrap it up, minus sign. Change the signs. Those cancel. So here I get my 8x. Bring down my 12. And all right, I'm going to multiply these terms by a positive 12. So it's going to get me 12x plus 24. Whoops, hold the phone. I actually need to multiply by a positive 8 to make those the same. So that's 8x plus 16. Wrap it up, minus sign, plus, minus, minus. So that leaves me with a negative 4 as my remainder. So how am I going to write this answer? Well, it's what I got for my quotient, x cubed minus 2x squared minus 4x plus 8. Now this time I'm not going to add, but I'm going to subtract because I got a negative 4 over my divisor of x plus 2. Okay. Now we're going to take the same problem but with the tabular method. Alright, so exact same problem. Let's carefully set up our table. So I know I have an x plus 2 on this side, my divisor. Now, I have an x and an x to the fourth. That means I need to multiply by x cubed. So after I have an x cubed, then I have an x squared, and then an x, and then a constant. So I need 4 terms going this way, or 4 columns. All right, and then I'm going to carefully put my answers in. So this one's going to be x to the fourth. Now be careful on this one. Don't put negative 8x squared next. Remember, you have 0x cubes. Then I'm going to have a negative 8x squared. And be careful on this one too. I have 0 x's and then a positive 12 at the end. All right. First block is always the easiest. It's just what you want your answer to be, x to the fourth, which means I need to multiply this x by an x cubed. And once I know that one, I can fill this column in. So that's going to be 2 times x cubed, or 2x cubed. Now I'll work this section because I know I have to get a total of 0 x cubes. So if I have 2 of them, the only way to get 0 would be to subtract 2x cubed. So now I say x times what is negative 2x cubed? Well, that would be a negative 2x squared. And now I can go fill this box in. So that's going to be a negative 4x squared. Okay, so now I'm going to focus on this group. I need to total negative 8x squared, and I already have a negative 4x squared, so that's going to make this a negative 4x squared, for a total of negative 8x squared. So then I'll say x times what gets me negative 4x squared, and that's going to be a negative 4x. And I can go get this bottom box, which is going to give me a negative 8x. And now I'll focus here and say, okay, I have to get a total of 0 x's. If I have negative 8 of them, then I must have positive 8 of them here, which means I'd have to multiply this x by positive 8, which would get me a 16 down here. Now, the only problem is they don't match. So what am I going to do? I'm going to take what I have and subtract that box to get a negative 4. So my final answer, just like we've done before, is going to be this quotient here. So the x cubed minus 2x squared minus 4x plus 8, and then minus, because I got a negative 4, over the divisor x plus 2. So again, you get the same answer. Whether you prefer the tabular or the long division, you should get the same answer either way. We're doing the exact same thing. All right, for our last example, we want you to find the quotient of 4x cubed plus 5x minus 8 over 2x minus 5. And here's what I want you to do. You can pick whatever method you're more comfortable with, whether it's long division or tabular, and I want you to pause it and do it on your own. I'm going to tell you what the answer is. I got 2x squared plus 5x plus 15 plus 67 over the 2x minus 5 divisor. Okay, so if you pick long division or tabular and you get that answer, you're in great shape. If you didn't, you need to continue the video and see where you made a mistake. So like I said, pause it, work it out. If you get this answer, I would say you're done for tonight. If you didn't get that answer, continue through the video to see where your error was. Good luck. So here's my work for my long division. You'll notice I have that 0 placeholder in there. And then just kind of go through and pause it and see if you can find where your error might have been if you're continuing to watch this. If you're looking for the tabular, it's coming up right next. So here's my tabular. My divisors here. I said the 4x cubed divided by 2x is an x squared, so I need the x squared, an x, and a constant, so I knew I needed 3 columns this way. Put my first box in there, and again I just showed that I match that up on what I'm adding to. At the very end, I have negative 8, and I want to subtract what was left over, a negative 75, to get that 67. Well, if you have any questions, we'll be around in the morning. Have a great night.